Okay, let's talk about some. You're following the last week's description on class diagrams and the relationships that you might discover between the different class diagrams, and let's see what some of the implications of those associations about those relationships. And in particular, we'll see some of the challenges of implementing some of those associations in a relational database. That not necessarily we will be able to implement all those kinds of associations, right? Some of the challenges that we have going from a UML representation and into a relational database representation, right? Sometimes it's trivial, sometimes it's not, and sometimes it's impossible, right? So let's take a look at first one that can be very easily implemented, and then we'll contrast it with some that cannot be implemented. Okay. So first, let's understand what it means when you create an association like this, right? For instance, if you have a student and you have a department, and that you have a one-to-many relationship between the two, this diagram implies that there is a particular constraint, right? There's a that explicitly says that if you have a student, that student can only be associated to one department. Okay, that's a constraint, right? This student cannot be associated to 2 or 3 or 4 departments. Yes. So the one-to-many relationship here, implicitly, right, implies, right, that student can possibly be only associated to that one department. Now, in a relational database, we can implement that, right, by using foreign keys and primary keys, and by referential integrity. The referential integrity imposes a constraint, right, that I can't, for instance, remove the department without if I have a particular student associated to that department. So already the database gives me the support to implement this constraint, right? So the constraint that is implied in the diagram can be readily implemented by a relational database using foreign keys and primary keys. Yes? So that's an easy one, right? Where going from a UML class diagram to a relational database is a one-to-one mapping, but not always. Right? It's not always as trivial as this example. Okay, so we will be adding more and more constraints to this to see where the limits are between going from a UML class diagram to going to an equivalent relational database schema. Okay. All right. So let's first look at one of them here. We've complicated things just a little bit. Now we have a three-way relationship where we have a student, we have a section, and we have a grade, right? Now, conceptually, this is just fine. We're saying that we have a three-way relationship between 3 different concepts, right? That we know that a student can be associated with any number of sections, right? A student can enroll in multiple sections, or you can read it the other way around. If you give me a section, there are many students that are enrolled in that one section. Make sense? It's not all the same students, obviously. Yes, I could be in section 1, 2, and 3, and some other student can be also in student. It could be in section 2, 4, and 5, but not in section 1 or 3. Make sense? Right? The same way, if I have section, if I give me a particular section, I might have students 10, 20, and 30. But if you give me a completely different section, I might have students 20 and 40, but not in 10 and 20. Make sense? Okay. Anyway, we can have any number of combinations between these two, right? And that's what this implies, many to many. I can have any combinations of a particular student in multiple sections or sections with multiple students. Now, this additional association that goes along here, what this says is that for any number of combinations of student and section, there's only one possible grade. Meaning that if I know the student and I know the particular section that student is in, there can only be one grade, which makes sense, right? I can only possibly have a particular grade in a particular section, right? And it would make no sense that I would be in the same section twice and I would have 2 different grades, right? This diagram doesn't allow that, right? It does not allow me to be in the same section twice, okay, and having a separate grade. right? So if for some reason I'm looking at the student 1 enrolled in section 1, they can only be one particular grade. If I look at the same combination of the same student and the same section, I can only possibly have one grade. Make sense? So that implies a constraint. If I know the section and I know the student, there can only possibly be one grade. That's the implied constraint. Yes? Okay. All right. Let's see if we can enforce this constraint, this rule, if we can enforce it in a relational database. All right. So we know that certainly we'll need to reify this, right? There's no equivalent of this dot, right, in a relational database. We'll need to replace this dot with an equivalent table. Yes? Yes. Exactly. Right, exactly. That's what the problem we're going to have, and we'll have to solve it. Yep. Now, in this case, we will be able to solve it, right, this first case. But then we'll look at a second case that we won't be able to solve it, right? And we like to look at the comparisons. Why could we solve it in one, but we couldn't solve it in the other? First, let's see where we can solve it, all right? So in this case, we're going to reify it. So we're going to replace this dot with a table, right, with an equivalent class that's going to keep this relationship, right? So we reify it, and now we have an equivalent grade assignment that has, notice that it has relationships to the student, has relationships to the section, and by necessity, it has to be a one-to-many relationship between the grade and the assignment. Okay. Now, as our colleague has pointed out here, we lost the constraint, right? Because this one, right? Notice that the way we would implement this in a relational database would be that we would have a foreign key to the grade, we would have a foreign key to the section, and we would have a foreign key to the student. Nowhere would we possibly be able to enforce the fact that a combination of these two, we can only have one of those. All right? There's nothing stopping us from having the same student, the same section, having one grade, and then later on, the same student with the same section, but a different grade. There's nothing stopping us from doing that. So the reification basically lost the original constraint. You see that? Right? We lost the constraint that was implied in the UML class diagram. We lost it when we reified it. Make sense? Let's try and solve that. Right? What could we do to fix it? So one way to fix it is that perhaps we can grab the foreign key that we use to point to the student and take the foreign key that points to the section and make it a unique combined primary key, right? That would force the combination to be unique, all right? And we could grab the grade and instead of making a separate, instead of having a separate class, perhaps bring it as an attribute into the table. Now we can perhaps enforce the original constraints, right? So we can fix it. We could fix it, right? This is the reification, plainly, right? This is the original reification that we get, right? We have a unique identifier from the enrollment. We have the grade. We have the student ID and the section ID as a foreign key that goes out to each one of those the other records, right? So to fix it, what we could do is to remove the EID, right? So remove this primary key over here, and then take this combination of student ID and section ID and make that the primary key, right? Now the combination is unique. There's no way that for the same student, for the same section, we could have two different grades, because we are saying that the combination of these two needs to be unique. There's no way that we could possibly insert the same two students and section, right? So this fixes it, right? We have now back to being able to enforce the original constraint, right? Because we can't choose this to be twice in the same record. Make sense? Okay. So yes, we were able to fix it. Now we can derive some some policies, right? Some principles from what we just did. Right? We try to generalize what we just did, an algorithm, right, as a policy. And the policy would be that, as a general principle, we're going to, on the weak side, these weak sides, right, we know those are going to become foreign keys. Right? So as a principle, we're going to take those foreign keys and we're going to make it the primary key of the reified table. Right? That's going to be the principle. And this grade over here, instead of having it as a separate, as a separate table, it's just going to be a field in the new reified table. So that's a principle. Right? That's the algorithm. Let's see if that algorithm can be applied generically. Right? Yeah. So some of the problems that we immediately see is that the algorithm assumes that the resulting table, indeed has references, has the foreign keys to the original classes that were there, right? But that is not necessarily guaranteed, right? We might have the foreign keys at first because that's part of the reification process, yes. But as we create the new reified table, we might identify that those new foreign keys introduce redundancies that weren't there originally. Okay, and we might find that we would like to remove that redundancy, right? Because there might be an alternative path, right, that was already there. That when we introduce this foreign key, it's now a redundant path that we could have followed in a particular different way. Okay, so yeah, so not always true, right? We might have removed it to remove redundancy. So let's look at an example, and we're going to deliberately introduce a problem, right, just to illustrate where our principle fails. Okay, so here's a class diagram from that we looked at last week, where we had a many-to-many between the student and the section, right? One student can be in many sections. One section can have many students. So certainly we would need to reify that, obviously. And then we have another relationship here of one course having many sections. This is fine. There's no problem with that. So now we're going to deliberately introduce a constraint, right? Just to show where our principle would fail, okay, where we could not fix it. For instance, we might say that a student can enroll in a section of a course, right? But now we're going to add an additional rule. You can only enroll in that course only if the student has not already been in that course, meaning you can't look to have the same course twice. That makes sense. That's a reasonable constraint, right? You can't enroll in 5200 twice, right? But notice that in our original data model, there was no way to capture that information, right? There's no way for us to know that you were already enrolled in that course, right? So before it was just, let's see, it was only students had many sections, and there was a one-to-many section, one-to-many between the course and the section. Okay? So we already had this. We already had this here. Yes? What we're adding is that we need to remember now, we need to record the fact that you were already in the course. So there's already a relationship between a student and a course. So that next time, if you try to re-enroll in the same course, we have to stop you. But we need to remember that you were in a particular course. So we're adding this relationship here between the course and the student. Yes? Right? So we want to make sure that we can stop you, right? That we need to remember it if we want to be able to stop you. Now, if we apply the principle, you'll notice here that we have an enrolls that goes into 1 in the section, and you have a many to the course, and you have a many to the student. That means that this reification over here is going to have a foreign key to the course. There's going to be a foreign key to the student. It's going to have a foreign key to the section. Yes? Right? But we're gonna take the two foreign keys that go out to the course and the student, and that's going to be our new primary key. Yes? Plus we're going to have the section embedded in here, so that we can enforce the uniqueness between course and student, which is perfect, right? Because we don't want the same combination of student and course more than once. Yes? Right? So the student and the course, the combination of those two, cannot happen more than once. Right? And that's how we're going to enforce the constraint. The resulting schema might be that the enrollment has, as a primary key, the foreign key that goes out to the course and the student. This is enforcing the constraint. Right? You cannot enroll, the same student cannot be enrolled in the same course more than once, because this would violate this primary key. Make sense? So this primary key enforces the constraint. Everybody okay? Plus the section ID that was brought into reification. Everybody okay? Right? Now everything else stays the same. The section has a section ID and a reference to the course. So that's the regular one-to-many relationship between the section and the course, right? And you just have the student and the course. So that's okay, right? So this is basically that implementation. There's our reification. There's the reification, right? We have a primary key that points to these two, and this has been embedded into the enroll, and the section has a one-to-many to the courses. Everybody good? Excellent. So this implements it. But now we see that we have inadvertently introduced a redundancy. Okay. Notice that the course. Notice that the enrollment here, it's pointing to the course, and the section is also pointing to the course. See that? All right. If, for instance, the student changes from one course to the next and say, well, I'm not in 5200 anymore, right? I'm in 5500. Okay? What's going to happen here? I'm forced to come in here and have to do two updates, right? I'm going to have to update this record, and I'm going to have to change this course to be, instead of 5200 to 5500, and I have to remember that I'm going to have to update this course as well, because you're in a different section for a different course. See that? All right? That's redundancy. Right? Whenever we're forced to update two records, right, because we need to remember that these logically have to be the same, right? That's redundancy. Right? We could inadvertently somehow forget, right, that we remember to do one but not the other, and that would introduce inconsistency. Right? It would make no sense that if I query the record of, hey students, what courses are you enrolled? And this tells me 5200. But if I query it this way, it tells me that you're in 5500. So that makes no sense. Right? You are either in one or the other. So that inconsistency stems from the risk of inconsistency. Right, stems from the risk of redundancy. Yes?
You say that you should remove the course ID but then it will
Exactly. Exactly. So now you have two bad choices. Right? You have two bad choices. You either remove the redundancy, you either remove this query, this section here, right? Or from here. But then you lose the constraint, or you remove the constraint and you keep you either fix the redundancy and lose the constraint, right? Or you keep the constraint and lose the redundancy, right? So you have two choices, two bad choices. Of neither one of them is a good choice. So that's called a conundrum. It's a conundrum. It says, well, you have to choose between two suboptimal choices. Right, what do you do? Right, there are no good options. Both of them are bad options. One of them you're not enforcing the constraint, so that means that you could be enrolled in two sections, in two different courses, twice. I'm sorry, in the same course more than once, meaning we're not enforcing the original rule, or you would be keeping the redundancy. That would introduce a risk of inconsistency. So the only possible option that you could have is to not enforce it in the database, because you can't enforce both, right? So you have to choose between two evils. Either keep the redundancy and handle the potential inconsistency, or remove the redundancy and handle the constraints violation, right? But you cannot enforce both, at least not in a database, not at the relational database, right? What you could possibly do is delegate that responsibility to the application level. Okay, you could let the application level do a query to a database, right, and then enforce the rules, and see that, oh, but you already enrolled in 5200. You're trying to enroll in something that you all have already enrolled, okay? And then at the logic, stop the user, say, no, you can't re-enroll in 5200. You're already enrolled in it. So at the application level, I can stop you there, right? Or deal with the redundancy also at the application level, right? And say, and know that I'll just need to remember to update both of them, right, at the application level. Okay. Again, both of them are suboptimal, but it's the best we could do. Make sense? All right. So this is just one of the first of many challenges we will be seeing throughout the semester, right? That a conceptual model doesn't necessarily map nicely into a relational database. Yes? That oftentimes you'll have to compromise, right, and settle for a suboptimal solution, right? Or solve it either with a stored procedure or implemented solve it at the application level, right? Yes.
If we encounter this kind of relationship
Yep.
in one of our contexts, how should it be?
Yeah, exactly. You would decide that you'll fix this at the application level, but you have to have a good reason not to actually solve it at the database, right? So that would be your last resort, right, to solve it at the application level. For instance, validation. Validation, even though you can do a lot of validation at the client side, you can do a lot of validation at the application level, it's always a good idea to also do validation at the database level, right? But validation at different stages is challenging, right? Because some things you cannot validate at the client side, right? And some things you cannot validate at the database level, right? So usually we try to validate as soon as possible and as often as possible, right? So that we minimize any chance of introducing bad data into our system, right? So same thing here, right? We try to enforce all these rules at all levels of the application, okay?